Yes, hello everyone. How are you, beta? Yes, just tell me how many of you are online? Yes. What about how many of you are online? Yes, just tell me. कितने लोग online हैं? Yes, fastly. Fastly कितने लोग online हैं बेटा? How many of you are online? Yes, how many of you are online? Just tell me. Yes, very good afternoon to all of you. Okay, Abhay. Very good afternoon, beta. Very good afternoon. Yes, what about others? Yes. Good afternoon, everyone. Today we are going to start with the geomatics engineering, and the topic is types of meridian and declination. Okay. Now, is there anyone who have the idea about what is meridian? Just tell me what is meridian. Is there anyone who have the idea of what is meridian? Meridian क्या है? Yes, बताइए. Abhay, you did not get any information till now. Yes, Abhay. अभी तक आपको इन्फॉर्मेशन नहीं मिला इसके बारे में, रोबोटिक्स और मैकेट्रॉनिक के बारे में? ना अभी मेरी टेक्निकल टीम यहीं पे है, वो आपको अभी एक आध लिंक भेज देगी थोड़ी देर में. ठीक है, आप यहीं ऑनलाइन रहिए, एक लिंक आ जाएगा अभी आपको थोड़ी देर में, मेरी टेक्निकल टीम आपको लिंक सेंड कर देगी. ओके, ठीक है. अभी ओके, अव्यका. Yes, we are going to start with the geomatics engineering, in which the today's topic is types of meridian and declination. Now, is there anyone who have the idea of what is meridian? Just tell me what is meridian. Yes. Yes, Avika. Any idea? Yes, Abhay. The link is shown in the chat portion. Just click on that link. You will get the idea about which courses we are offering. Okay. Now suppose that this is the surface of the earth, which is roughly in the shape of spheroid, just like this. Okay. Now here the north pole will lie and here the south pole will lie. Okay. Now the line which joins the north pole and the south pole along the surface of the earth, this line is known as nothing but the meridian. Okay, this line is known as the meridian. Abhi, can I just teach all the subjects to all these students? Okay, the link is shown here. Just click on that link. You will get the idea about which courses we are offering. Okay, just click on that link. Now this is known as meridian. This is known as meridian. Now when this north pole and south pole becomes magnetic north and magnetic south, just listen to me. When this pole becomes magnetic north and magnetic south, so the line which joins the magnetic north and magnetic south pole is known as nothing but the magnetic meridian. Okay, this line is known as the magnetic meridian. Now, similarly, if a line joins true north and true south. Now, what is true north and what is true south? We will discuss. Okay, we will discuss what is true north and true south. First of all, we need to understand what is true meridian. After that, we will discuss what is true north and what is true south. Yes, Abhay, you have to download the Ekeeda app. After it, you need to just go and refer which courses we are offering. Okay, true north and true south. Now the line which joins the true north and true south on the surface of the earth, this is known as nothing but the true meridian. Clear? Now just listen to me. Suppose that we will have the magnetic meridian here. We will have the magnetic meridian here, somewhat here. We will have the magnetic north here and magnetic south here. Now suppose that if any object will lie somewhat here, then the position or the direction of this object will be equals to what? Alpha. Now is that alpha will be constant for all the days? Yes, just tell me, is that alpha will be constant for all the days? Fastly. Yes, just tell me, is that alpha will be constant for all the days? If earth is continuously rotating or revolving, is that alpha will be constant for this object? Yes, just tell me. Fastly. Yes. Is that alpha will be constant for this object? Just tell me. No. Now, what happens? Suppose that tomorrow, due to the rotation of the earth, the magnetic north will reach up to this point. Because the earth is continuously revolving around its own axis, suppose that magnetic north will reach up to this point and magnetic south will become here. Now, object will lie here only. Now, the angle from the magnetic north or the bearing from the magnetic north will change here. That is alpha dash. So we cannot take the magnetic meridian as reference axis because it is not constant. It is changing as per the rotation of the earth. That's why we cannot take the magnetic north or magnetic south pole as reference axis. So what we need? We need a reference axis or a meridian which does not change its position with time. So what is that meridian? That meridian is known as what? True meridian. Now what will happen with true meridian? Now just listen to me. We assume that there will be an arbitrary meridian on the surface of the earth whose position is always just like this. Okay, whose position is always just like this, that is a true north and true south. Now today also the position is just like this. Tomorrow also the north pole and south pole will be just like this, that is a true north and true south. And day after tomorrow the position is just like this, that is a true north and true south, just like this. Okay. Now, what will happen? Suppose that today magnetic north and magnetic south will also lie here only, that is coinciding with true north and true south. So, what is the angle between true meridian and magnetic meridian? Just tell me. What is the angle between true meridian and magnetic meridian here if both will coincide with each other? Just tell me. What is the angle here? Yes, fastly. Fastly. Zero. Very good, Shivnanda. Very good. Zero. Now suppose that an object will be lying here. Now the angle from the true meridian is known as what? True bearing. The angle from the true meridian is known as what? True bearing, and the angle from the magnetic meridian is known as magnetic bearing. Now, today, both the meridians are coinciding with each other. That's why true bearing and magnetic bearing will be same for this line. Okay. Now, suppose that the object will lie here. Now, true bearing will be equals to what? The same true bearing which will be find out previously will be same here also. Now, it will be same here also. So, true bearing will be same at all the times. So, it will not change with the time. Now, suppose that what will happen with the magnetic meridian? Now, today the true meridian and magnetic meridian will coincide with each other. That's why the true bearing and magnetic bearing will be same. Now, what will happen tomorrow? The true meridian will lie here, and this is the true bearing. But due to the rotation of the earth, what will happen? The magnetic meridian will reach up to this place that is known as magnetic north, and that is known as magnetic south. Now, is the true bearing and magnetic bearing will remain same? Just tell me. Now, this is the magnetic bearing of this object. Is the true bearing and magnetic bearing will same for this object? Just tell me. Yes. Yes, firstly, if the position of magnetic north will change, it will move towards westward side of the true north. Then is the true bearing which is marked by green line and the magnetic bearing which is marked by black line will be same or not? Just tell me. Yes. Just tell me. Is it same or not? Yes, fastly. Are you understanding this concept? Just tell me. Are you understanding this concept or I need to explain it once again? Just tell me. Yes, fastly. Once more. Okay, we will discuss it once more. Suppose that true north and true south pole is an imaginary line, okay, which will always lies on the surface of the earth just like this. That is the true north and true south. Now, today the position of true north and true south will be like this. Tomorrow, the position of true north and true south will lie just like this. And day after tomorrow, the position of true north and true south will be just like this. It means that at each and every time the position of true north and true south will be same. It means that it will not change with time. Now suppose that there will be an object which is lying here. There will be an object which is lying here. Now the angle which is measured from the true north in the clockwise direction is known as nothing but the true bearing. So this is known as the true bearing of this object. Okay, this is known as the true bearing of this object. Now tomorrow also the object will lie here only, and day after tomorrow also the object is lying here only. So what this angle will be, this is known as true bearing, and this is also known as true bearing. So true bearing will never change with time. True bearing will never change with time. Okay, that is the concept of true bearing, and this is known as true meridian. The line which joins the true north and true south along the surface of the earth is known as true north and true south. Now suppose that today only the magnetic north and magnetic south will lie here only. The magnetic north and magnetic south will lie here only. Now what will happen if magnetic north and magnetic south will lie here only? Then the angle which is marked from the magnetic north in the clockwise direction up to that line is known as nothing but the magnetic meridian, or sorry, magnetic bearing. The angle which is marked from the magnetic north in the clockwise direction up to that object is known as magnetic bearing. Yes, Shivani Chauhan, very good afternoon, beta. Very good afternoon. So, in today's case, is the true bearing will be equals to magnetic bearing or not? Just tell me. Yes, just tell me. Okay, Shivnanda. And the angle between the true meridian and magnetic meridian will be equals to what? It will be 0. Is it or not? The angle between, शिवानी मैंने अभी ज्यादा नहीं पढ़ा है बेटा, अभी सिर्फ और सिर्फ मैग्नेटिक मेरिडियन की डेफिनेशन डिस्कस की है कि मैग्नेटिक मेरिडियन वो एक्सेस होता है जो मैग्नेटिक नॉर्थ और मैग्नेटिक साउथ को जोड़ता है, और उसको हम लोग रेफरेंस एक्सेस नहीं मान सकते क्योंकि वो कंटिन्यूसली चेंज होता रहता है। अब अगर उसको रेफरेंस एक्सेस नहीं मान सकते तो किसको रेफरेंस मानना पड़ेगा? तो ट्रू मेरिडियन को रेफरेंस एक्सेस मानना पड़ेगा। ट्रू मेरिडियन क्या होता है? वो लाइन जो ट्रू नॉर्थ एंड ट्रू साउथ को जोड़ती है। अब ट्रू नॉर्थ एंड ट्रू साउथ कुछ होता नहीं है, ये सिर्फ इमेजिनरी होते हैं। क्यों माना हमने? ताकि हम एक रेफरेंस एक्सेस बना सकें। तो हमने बोला कि ट्रू नॉर्थ और ट्रू साउथ हमेशा, ये जो ब्लैक लाइन बनी हुई है हमेशा ऐसा दिखेगा, और ये कोई ऑब्जेक्ट है, ठीक है, इसकी पोजीशन हमने निकाली ट्रू नॉर्थ एंड ट्रू साउथ से, तो ये ट्रू बेरिंग निकली है हर बार। नाउ आज की डेट में क्या हो रहा है? मैग्नेटिक नॉर्थ और मैग्नेटिक साउथ भी यहीं लाई कर रहे हैं जहां ट्रू नॉर्थ और ट्रू साउथ लाई कर रहा है। तो दोनों के बीच में एंगल कितना बनेगा? ट्रू मेरिडियन एंड मैग्नेटिक मेरिडियन के बीच में एंगल कितना बनेगा? यस, व्हाट इज द एंगल व्हिच इज फॉर्मिंग इन बिटवीन द ट्रू मेरिडियन एंड मैग्नेटिक मेरिडियन? जस्ट टेल मी। यस, फास्टली फास्टली। 0. So here the angle will be represented by declination and it is known as 0. Now declination is that angle which is formed in between magnetic meridian and true meridian. Now suppose that day after tomorrow or tomorrow only, due to rotation of the earth, magnetic north will reach up to this point and magnetic south will reach up to this point. Now this is the magnetic meridian and this is the true meridian. Now the angular difference between these two will be known as what? Declination. Is it clear to you? Yes. The angular difference between true meridian and magnetic meridian will be known as declination. Clear to you or not? Yes, fastly. Fastly. Is it clear to you? Okay. Now the angle which is measured from the magnetic north in the clockwise direction up to that object will be known as what? The angle which is marked from the magnetic north in the clockwise direction up to that object will be known as what? Just tell me. I had explained here only. What is the angle which is measured from the magnetic north in the clockwise direction? Just tell me. Yes. Shivani, Shiva, just tell me. Firstly, what is this angle? क्या कहेंगे हम इस एंगल को? What we call this angle? It will be known as what? It will be known as magnetic bearing. Is it or not? Is it or not? That is known as magnetic bearing. Okay, Shivani. Now, if magnetic bearing is known and if declination is known, then what will be the value of true bearing here? Then what will be the value of true bearing here? Is it? It will be equals to magnetic bearing minus declination. Is it or not? Is it or not? That is magnetic bearing minus declination. Okay. Yes, Shivananda. Now suppose that due to the rotation of the earth, okay Shivani, very good beta. Now due to the rotation of the earth, suppose that magnetic meridian will reach up to this point, that is the magnetic north and that is the magnetic south. Now the angular difference between true meridian and magnetic meridian will be known as what? Just tell me. The angular difference between true meridian and magnetic meridian will be known as what? Just tell me fastly. Yes, fastly. The angular difference between true meridian and magnetic meridian is known as what? Just tell me. Yes. Declination. Shivani, that is declination beta. Okay. That is declination, which is represented by delta here. And the angle which is marked from the magnetic north in the clockwise direction up to that object will be equals to what? Yes. The angle which is marked from the magnetic north in the clockwise direction up to that object will be what? Just tell me. Magnetic bearing. Very good, Akhilesh Kumar. Very good. It will be known as magnetic bearing. Now, if magnetic bearing is known and declination is known, then what will be the formula of true bearing? Just tell me, what will be the formula of true bearing here? Yes. Yes, fastly. It will be equals to, very good Akhilesh, it will be equals to magnetic bearing plus declination. Clear? So these are the three possible cases which will exist uh, due to the rotation of the earth or revolution of the earth. Yes, Shivani, very good beta, very good. Now that's why I had written here, true north and true south are imaginary poles, hence true meridian is also an imaginary line. Now true north and true south will never lie on the earth's surface because it is an imaginary line. But why we had taken that? Because we want some reference axis which will be remains fixed, okay, at each and every time on the surface of the earth. That's why we had taken a reference axis which is known as true meridian. Now, the position of magnetic north and magnetic south will depends on the revolution of the earth. As the earth tilts about its polar axis, the position of magnetic north and magnetic south is also changed, due to which direction of magnetic meridian changes. That's why we cannot take the magnetic meridian as the reference axis because its position is not fixed. Clear? Till now it is clear to you? Yes. Just tell me. Till now it is clear to you what is bearing and what is declination? Yes. Okay, Shiva. Now, bearing of a line, we had already discussed that if we will measure the angle, from the north pole and from the south pole, then it is known as bearing. If we will measure the angle from the magnetic north and magnetic south, and last point, repeat. Which last point? This one, Shivani. It means that when the earth is revolving around its own axis, then the position of magnetic north and magnetic south is also changing. Now if the position of magnetic north and magnetic south is changing, then we cannot take the magnetic axis or magnetic meridian as the reference axis, because if we take that axis as the reference axis, suppose that if this will be the magnetic north, and if we will take the direction of this object with reference to magnetic north, then this will be alpha today. Now tomorrow what will happen? The position of magnetic north will change somewhat here and the object is lying here. So is the angle will remain same tomorrow also? Just tell me, is the angle will remain same? No. So if the angle will not remain same, then we cannot take that axis as the reference axis. That's why we had changed our reference axis to the true meridian. Clear? Clear, Shivani? Yes, Kamrul. Very good afternoon, beta. Very good afternoon. Now it is clear. Okay. True bearing is fixed, but magnetic bearing is not fixed. Yes, Akhilesh. Very good, beta. Very good. Now, if we will measure the angle, now it is marked here wrongly. Okay. Now, suppose that this will be a line. This will be a line PQ. And if we will measure the angle from the North Pole in the clockwise direction, then that theta will be known as bearing if it is measured from the North and South Pole. And if that angle will be measured from the magnetic North and magnetic South in the clockwise direction, then that angle will be known as magnetic bearing because it is measured with reference to the magnetic meridian. And if any angle will be measured from the true north and true south in the clockwise direction, just like this, then it is known as true bearing. Is it clear to you? What is bearing, what is magnetic bearing, and what is true bearing? If we will measure from north and south, then it will be known as bearing. If we will measure from magnetic north, then it will be magnetic bearing. And if we will measure from the true north, then it will be true bearing. Clear? Yes, firstly. Done. Done. Just tell me. Okay. Now, if it is clear to you, now we are moving towards the declination. We had already discussed the angular difference between magnetic meridian and true meridian at any place is known as declination. Now, suppose that if the magnetic north will lie in the eastward direction or in the rightward direction of true north, then it is known as declination. And if the magnetic north will lie in the westward direction or leftward direction of true north, that it is also known as declination. But this declination is known as what? Negative declination, because it is on the left side of true north, that's why it is known as negative declination. And if the declination is on eastward side, then it is known as positive declination. Clear? Yes. That's why I had written here, if magnetic north is leftward of true north, if magnetic north is leftward of true north, then the declination is anti-clockwise or negative. And if the magnetic north is rightward of true north, then the declination is clockwise or positive. Clear? Clear? Yes. Done. Now suppose that this is the surface of the earth. Yes, it is measured clockwise and it is measured anti-clockwise. Now suppose that this is the surface of the earth. This is surface of the earth. Now at this line, what will be the declination angle here? If magnetic north and true north will lie same here only, then declination will be equals to 0. Is it or not? Is it or not? Yes. Now suppose that when we just draw the line on the surface of the earth, when we draw the line on the surface of the earth from these points, now what will happen? What will happen? Just listen to me. What will happen? Suppose that at the declination equals to 0, at the declination equals to 0, England will lie, Australia will lie, Finland will lie. Okay. So the line which joins the point of 0 declination on the surface of the earth, it means that when a line joins that places which is having declination equals to 0, then that line is known as nothing but the agonic line. Clear? It means that the line which joins the point of 0 declination is known as agonic line. Clear or not? Just tell me. Okay. Yes. And suppose that if the declination is minus 5 degree, suppose that the declination is minus 5 degree, it means that the object is lying here. The line will lie here when the declination is minus 5 degree. Now suppose that this will be the position when the declination is minus 5 degree. Now all the points or all the countries which are having the declination equals to minus 5 degree, now the line which joins that country or the line which joins the point of same declination, not 0 declination, now the line which joins the point of same declination is known as isogonic lines. Clear? Clear or not? Yes. The meaning of agonic and isogonic. Yes, just tell me fastly. Okay, Shivani. Now, the relation between true bearing and magnetic bearing, we already discussed that. Now, if magnetic bearing is known, if declination is known, then what will be the true bearing here? It will be equals to magnetic bearing plus declination. And in that case, if magnetic bearing is known and declination is known, then true bearing will be equals to what? It will be equals to magnetic bearing minus declination. Is it or not? Just tell me. Is it or not? Yes, firstly. Okay, Shivani. Thanks, beta. Okay, so that is the relation between magnetic bearing, declination, and true bearing. Now, what do you mean by dip of the magnetic needle? Now, just listen to me. What do you mean by dip of magnetic needle? Now, suppose that when you just freely hold the prismatic compass or surveyor's compass in the open survey area, then it should be remain as the horizontal needle. Is it or not? It should remain as the horizontal needle. Is it or not? Just tell me. Yes. If you just freely suspend the compass in the field, then the needle of the compass should be just like this. That is the perfectly horizontal. Is it or not? Yes. Firstly. फास्टली। अगर आप निडल को या कंपास को आप फील्ड एरिया में रख देते हो, सिंपली फ्रीली सस्पेंड कर देते हो, तो निडल को हमेशा हॉरिजॉन्टल होना चाहिए। क्लियर? नाउ अगर किसी वजह से, नाउ if by any means the position of needle will become just like this, the position of needle will become just like this, then the difference between the horizontal axis and the needle of that compass will be known as nothing but the dip of the magnetic needle. It is known as the dip of the magnetic needle. Is it or not? Yes. इसी को हम लोग डिप ऑफ द मैग्नेटिक निडल कहेंगे। अगर किसी वजह से आपका निडल जो है वो इंक्लाइंड हो जाता है, तो जो इंक्लिनेशन आया हॉरिजॉन्टल से उसका, उसे हम लोग डिप ऑफ द मैग्नेटिक निडल कहेंगे। हाँ या ना, बताइए। यस, जस्ट टेल मी। यस, फास्टली, जस्ट टेल मी। फास्टली। Done or not? Okay. Now the line which joins the point of same dip. Now the line which joins the point of same dip on the surface of the earth, they are known as isoclinic lines. Isoclinic lines. And the line which joins the point of zero dip is known as nothing but the aclinic lines. Okay. So agonic lines are those which is joining the point of zero declination, and aclinic lines are those which is joining the point of zero dip. Similarly, isogonic lines are those which joins the point of same declination, and isoclinic lines are those which joins the point of same dip. Dip occur due to magnetic things contact with compass like watch. Definitely it will be due to the high tension wire which is going over that area, or it will be due to some steel structure which is nearby that field area, or it will be due to the mobile phone which you are carrying in your pocket, or it will be due to anything which you had wear in your hand that is of metallic nature. Okay, so by that type of magnetic things there will be a dip of the magnetic needle. Is it clear to all of you? Yes, just tell me, is it clear to all of you that what is isoclinic line, what is aclinic line, what is isogonic line, and what is agonic line? Yes, just tell me, is it clear to all of you? Just tell me fastly. Yes. Okay, Shivani. Now we are moving towards the question. Suppose that in an old map, a line PQ was drawn to magnetic field of 4 degree 30 minute, and the magnetic declination at that time being 2 degree east. Now the present magnetic declination is 8 degree 30 minute east. The magnetic bearing to which the line to be set at present is. It means that we need to determine the magnetic bearing of the present time. Now just listen to me how I am going to solve this numerical. Just listen to me. Okay, you will get an idea about how to solve this type of numerical. Clear? Now, first of all, you need to prepare here the true north position, that is at old time as well as at present time, that is the true north and true south which I had prepared here. Now second thing is what? You need to mark the declination. You need to mark the declination after preparation of the true meridian. Okay. Now in old time, the declination was 2 degree east. It means that the declination was 2 degree east, just like this. So that will be the position of magnetic north, and that will be the position of magnetic south, and this angle will be equals to what? 2 degree. Now at present time, the magnetic declination is 8 degree 30 minute east. It means that the magnetic north will lie somewhat here, and the angle will be equals to what? It will be equals to, the declination will be equals to what? It will be equals to 8 degree 30 minute east. Clear? Now in old time, the magnetic bearing was given as 4 degree 30 minute. Okay. Now magnetic bearing is measured from the magnetic north in the clockwise direction. So it will be equals to what? 4 degree 30 minute. That will be the magnetic bearing of line PQ. This will be the line PQ, and this angle will be equals to what? 4 degree 30 minute. Now we cannot take the magnetic axis or the magnetic meridian as the reference axis. So we need to determine this angle from the true north, which is known as true bearing, because true bearing will never change. मैग्नेटिक बेयरिंग चेंज हो सकता है, पर ट्रू बेयरिंग कभी भी चेंज नहीं हुआ, किसी भी हालात में चेंज नहीं होगा. सो ट्रू बेयरिंग कितना हो जाएगा इस केस में? व्हाट विल बी द वैल्यू ऑफ ट्रू बेयरिंग? इट विल बी इक्वल टू व्हाट? मैग्नेटिक बेयरिंग प्लस डिक्लिनेशन. So it will be equals to what? 4 degree 30 minutes plus 2 degree. So it will be equals to what? 6 degree 30 minutes. Is it or not? That is the true bearing of line PQ. Yes, just tell me. Is it or not? That is the true bearing of line PQ. Clear? Done? Now, the true bearing will never change. So we will draw the true bearing of line PQ here. That is the point P and that is the point Q, and the angle will be equals to what? 6 degree 30 minutes. Now we have to compute the new magnetic bearing of line PQ as per the present scenario. Now as per the present scenario, what will be the new magnetic bearing? Magnetic bearing will be measured from the magnetic north in the clockwise direction up to that line. So up to that line, this will be the magnetic bearing. Now if we will measure from this point and we will finish at this point, then the complete angle will be equal to 360 degree. And this angular difference will be equals to what? It will be equals to 8 degree 30 minute minus 6 degree 30 minute, because the angle which is measured from the true north to the magnetic north will be equals to 8 degree 30 minute, and this will be equals to 6 degree 30 minute. So the total angle difference between these two lines will be equals to what? 2 degree. So this angle will be equals to what? 2 degree. Now you just subtract. If you need to determine this magnetic bearing, you need to subtract the 2 degree from 360 degree and you will get 358 degree as the magnetic bearing. Is it or not? Just tell me. Is it or not? Yes. That is the way how can we calculate the magnetic bearing at different times. Clear? Yes. Okay. Now in this way you need to solve all the question. I will give you one question as homework. Just take that question as homework. When we meet on next Thursday, we will discuss that question. Okay, just take that question as homework. This is the question which is given as homework. Just take that question snap as homework. Okay, just take the snap of that question as homework. Done? Done? Yes, fastly. Done? Done, Shivani? Yes, just tell me. Okay. Now, what is the time of our class? Shivani, we had changed the timing of our class. We had just shifted our time to 3 p.m. Okay, now from Monday to Friday we will have the classes from 3 p.m. to 4 p.m. only. Okay, clear? Okay, Shivani, we will have our timing of class from 3 p.m. to 4 p.m. Now on this positive note, I am finishing the class here only. Bye bye. Okay, just be safe and पढ़ाई वढ़ाई करो यार. Okay, चलो bye bye.